Hi, I'm Linda Jordan, and I will be the instructor for this session, More Analysis, Less Coding with SAS Viya for Learners. I have been at SAS since 1998, teaching our classes and developing our courses. I joined our SAS Global Academic Programs team last summer. And I'm very excited to present this session using the SAS Viya for Learners platform. Viya for Learners is a platform that is available to anyone that has a .edu email address. We have Viya for Learners and another platform, SAS On Demand for Academics, that are free resources for anyone in academics. Viya for Learners is a platform that is similar to our standard Viya deployment that you may have at your company. Everything that we do in this session can be done on a traditional Viya deployment. So Viya is the platform, and on the platform, we have a variety of different applications. The applications that we will focus on today are going to be visual analytics and visual statistics. But just so you know, we do have other applications like visual text analytics, visual data mining and machine learning, and Model Studio. All of these applications are a no-code or low-code application, which means we really don't have to write much code. We do have our traditional programming platform available as well. Within Viya, as I mentioned, we do have a lot of different applications. For our focus, we will start in SAS Drive and then navigate to Visual Analytics. And within Visual Analytics, we can find visual statistics and visual data mining and machine learning. Visual statistics is going to be our main focus for this session. So what is visual statistics? Well, it is an add-on. So it is part of visual analytics, and it allows for us to build and modify predictive models. So this gives us access to the CAS server, which is running behind the scenes, that can quickly and efficiently analyze our in-memory data. It allows for concurrent access for multiple users, so it's not just a one person at a time. You can have multiple people working on the platform at the same time. And it is very fast. We have a lot of data preloaded into Viya for Learners. So as I'm demonstrating today, you'll see that there are many data sources. So feel free to come back and visit some of these tasks that we learn with some of the other data sources. Visual statistics is an exploratory modeling software application. It allows for you to create clusters. It allows for you to create partitions. You can derive predictive outputs. You can run multiple models and then compare those models, which will allow for you to select a champion model, and then you can put that champion model into production with your other SAS applications. So we will start the session today in SAS Drive. This is the first place or the landing place that after you have logged into Via for Learners or Via, you will see this screen. And again, this is SAS Drive. Keep an eye on the top. That blue bar will always tell you what application you are in. We have this applications menu if you want to play around or navigate to other applications. My SAS Drive will look a little different because I've been using it for a while and I have a bunch of items saved on it, but in general, it will look this way with a quick access area and the canvas. Again, we will be using SAS Visual Analytics to access SAS Visual Statistics. SAS Visual Analytics allows for multiple pages. In the left pane, we have our data and the objects that you want to work with. You can just drag the object into the canvas and then populate it with the data items. On the right-hand side, we have lots of different options that can modify the object that you have selected. So let's jump in to our demonstration. I will introduce SAS Via, SAS Visual Analytics, and SAS Visual Statistics. We will see how we can explore relationships among the variables in the course data. We will perform cluster analysis and logistic modeling. I will be using SAS Via for Learners for the demonstration, so I'm going to go ahead and launch that platform. Again, everything that I demonstrate is available on any deployment of Via. So this is SAS Drive. Note in the top in the blue bar, this is the application bar. And over on the left-hand side is the application menu. Now mine will look a little different than yours. I have a lot of reports and queries that I've worked on. And then I have a couple things here. This is our quick access area. So this gray area at the top is our quick access area. I'm not going to use any report that I've already created. Instead, I want to start fresh. So I will select the application menu, and from the application menu, I will select Explore and Visualize. This will open SAS Visual Analytics for us. I have a couple options here. I could open an existing report. I could create a new report, or I could start with data. So these options are very similar. I could select new report and then go get data, but I'm just going to select the start with data. The data source that I want to use for this demonstration is fictitious data from the communications sector, and I believe it's called comms data. There we go. When I select it, just single click, it shows me the data source names, their labels, their types, and formats and so forth. Over on the right-hand side, I see there's 128 columns and 56,600 rows. I can select this sample data tab and it'll show me the first 100 rows of the data. I can also select the profile, and this is going to run metrics on my data. So it tells me that I do not have any duplicate customer IDs. That's probably interesting and important to know. Otherwise, it gives me sort of descriptive statistics on the rest. I want to go ahead and select OK down in the lower right-hand corner. And you can see that the data has been loaded into Visual Analytics. Remember, the blue bar at the top will tell you what application you are currently in. So it lists all of the categorical data first, and these values next to the categorical label represents the distinct values or the distinct count of values. So I have 9 different account regions. As I scroll down then, you can see all of these measure data, which is quite extensive. And we will not be using all of that. So our goal is to use visual statistics. But before I show you the visual statistics objects, we need to do some basic exploration of our data. So let's quickly look at some of these objects that we might want to use. We have some tables. We could do a crosstab or just a listing. I can do bar charts, box plots. We can kind of keep going through this. Histograms. I have geomaps. Controls are objects that allow the viewer of the report to filter the data on the fly. Then I have some objects that are more analytical in nature. And finally, I have the visual statistics objects. And we will be focusing on the cluster and logistic regression. Note, we also have some objects for visual data mining and machine learning. We need to be comfortable navigating through visual analytics. So a couple things I want to point out. The 3 dots, they are in a variety of places. This will give you a menu. Regardless of where you click it, it will give you a menu. So when you're looking for an option, sometimes they're over here in the right-hand side for options. Other times they will be in the upper right-hand corner. These would be report-based options. These would be page options. And then these are options for the objects. And when we're working with an object, that will have options as well. And we'll take a look at that. So let's talk about this data that we're going to be using for our demonstration. This data is customer churn data. And what does that mean? Well, it is data indicating whether or not the customers churned. That means, did the customer leave? It's a lot more expensive to recruit new customers than it is to maintain existing customers. So we want to use this data to analyze which customers are most likely to churn. Who may leave us? We have about 10 months of data. So that is what we'll be looking at. And again, we have a handful of categorical data. A couple things I want to point out. Here is our churn flag. Because it has the values of 0 and 1, it has been put in the measure column. Well, we need to make that categorical. So we just expand the properties and then classification and change that to category. And now, when we go up here, we see our churn flag. Visual Analytics has a fantastic feature called Auto Chart. I can just drag my column over into the canvas and release it. And it will determine the best possible graph to display that data. So 0 means they didn't leave, 1 means they did. it's currently displaying the frequency count. We could go over to the roles icon in the right pane and select frequency and change it to any measure we want. Well, I actually just want to change it to frequency percent. The graph will not look any different, but when I hover here, it'll tell me that we have about a 12% churn rate. So we lose about 12% of our customers. And again, this is a 10-month window. So this is kind of interesting right out of the gate. If we continue to look at the data, you will see there are a handful of data items similar to the churn in that they are a 0, 1. So do you own an Apple phone or Apple device, HTC, LG, and so forth. Again, if I wanted to change these to categories, it is quite easy. I'll do this one, but we don't really need these items. We're not going to be using them. So we can leave them as is. But it is quite easy to change the attributes of a data item. In fact, we have several measures that are reporting average, but again, when I expand the properties, it says it's summing them. So I would just go and change these to average. I know we want to get into analyzing our data, but we need to make sure that we have some clean data that we can analyze. And we need to understand some relationships within the data. I'm going to go ahead and add a page. I'm going to leave this churn graph here. I'm going to add a page. And within the objects, we have something called a correlation matrix. And this is fantastic to look at the relationship between measures. Okay, I'm going to go ahead and select some of these variables, not all of them. So let's select assign data, add, and then I'm going to go ahead. So I want the total MB data roaming usage. And then I want the current data usage, and I want, let's go back to our filter. Let's see, I'm going to grab a bunch of these. My calls incoming, outgoing, total calls. Do we get peak, off peak? Excellent. And let's see, we want some billing information. And we expect that there will be some relationships here. And let's grab a few more, and then we can grab up to 60. So we're going to see all of the, okay. I think that's enough for right now. You can always come back and add more. So I'm going to go ahead and select close. So the darker the blue, the stronger the relationship. And let's see, calls incoming off peak is highly correlated to total calls. Not a big surprise, right? Same here, total calls, strong relationship with calls incoming peak. So when I'm seeing these very strong relationships, I just want to note that I don't want to include both of these data items in my model. So maybe I'll take total calls out, and over in the right-hand pane, I can select the data item I want to remove and then just select Remove the Data Item. And so now that's gone. Data usage amount, moderately correlated with total build data usage. Let's just remove this one as well. Let's see, total megabytes of data usage, and then the roam. So that's also not a big surprise, is it? Oh, did I remove the wrong one? I did. It's okay. I like to use this correlation matrix to learn a little bit more about my data before I go in to build any models. In addition to the correlation matrix, we have a couple other objects within Visual Analytics that you might want to take a look at. We have histograms to look at the distribution of the data. We have box plots, which are very useful to look at the variability in the data. Our goal for this session, though, is to investigate visual statistics. So I want to move ahead into visual statistics, and we will start with our unsupervised model, which is cluster. So our cluster model is our only unsupervised model. To perform the cluster analysis, we need to assign some data. I'll select the assigned data in the center, and then I can go into the data items and select as many items as I would like. Now remember, we are looking to understand why we lose customers. So let's see what might play a part in this. I'm going to go ahead and select some continuous and some categorical data items. So let's see, maybe region could play a part. The overage charges would be interesting to look at. Our 9-month average build data usage, account tenure. Remember, what we're going to do here is group observations that are as similar to each other while being as different from the others. So that's what's going to happen with this cluster analysis. One of the really nice things about visual statistics is that it is really easy to add and remove values. Okay, let me just pick a couple more data items. Let's see how that looks. And I'll select close. Again, I can come back and add or remove some of these data items depending upon what I see here. So we've got two objects. I'm going to go ahead and separate them so that they're on their own pages. And we can do this by going to the objects on the right-hand side and change our plot layout from fit to stack. Okay, so these are individual groupings, and while it does look like there's like overlap, there really isn't, because we can only see this in a 2-dimensional angle, but if we could see it in a 4-dimensional display, then we could see that these are actually individual segments. by default, it will always do 5 clusters. We can change that. That's just the default number of clusters. So we've got these 9 different regions, and you can see that. So for the data usage, we've got mostly our cluster 1, and then for the higher data usage, we have our cluster 3s. And for account tenure, for the lower values, again, we have mostly cluster 1s, and then the higher values tend to be cluster 4s. For the 9 months average build is cluster 1 at the very low values, and then cluster 2 with a couple outliers. And as far as the regions go, we see that cluster 5, this is the 3-month average. So I think that I may remove the account region. Okay, so looking at this, I see cluster 5 is on the low end of our income, the low end of data usage, the lower end of account tenure, billing data. We see that the 9-month average bill data usage looks like it's spread out. I've got a little bit of everything, but the account tenure seems to be more in the orange in the upper portions. And then we can see that again here. It's just kind of flipped, so looks a little different. But the point here is that we are building these clusters, and these clusters represent segments of my data. And again, the idea here is that the observations in each cluster are similar to each other and different from the other clusters. And the reason that we do this is that I could write out these clusters and then use them later on in another analysis. Remember that this is an unsupervised model, so I do not have a target variable. We have some options if you're interested. You can change the number of bins. We can change the number of clusters. I'm going to go ahead and leave them as is. The initial assignment is through 4G. We could change that to random. I really want to write these clusters out. That is what I would like to do. So I'm going to go ahead and derive cluster ID items. And I'll just leave it cluster ID. I'm going to remove that one, and we'll select OK. The other piece of this is just another way to look at this data. And this is a parallel coordinates plot. And so we can see that looks like our ones are sort of on the lower end of most of our observations, and our 5s are very low in the build data usage. And in the lower portion for our account tenure, the oranges are very much higher in the account tenure. The 3s seem to be high in data usage, and then those 5s seem to be in the higher end of our estimated household income. So this is just another way to look at the data and the different groups that have been created. And again, I'm going to use this when we go into logistic regression so that we can take a look at the logistic regression broken down by different groups within my data, different segments of my data. So I'm going to go ahead and start a new page. On our new page, we will select the logistic regression object within the visual statistics category and just drag and drop that into the center. And so in the background, I have what will look like our logistic regression or something similar. So the first thing I need to do is assign some data. What's going to be our response variable? Well, we are trying to predict whether or not our customers churn. So I'm going to select the add and I'm going to select the churn flag. And then as far as continuous effects go, I have a bunch that I'm going to select. So just bear with me. Again, because this is exploratory, I have a lot of flexibility as far as what I want to put into my model. And because this is point and click, I can drag and drop, remove things on the fly. It's just super easy for me to make changes. I'm not going to sit here and wait for it to run. It's super fast. Okay, I think we'll start with this. Again, I can always come back and grab some others. And I did not add any categorical data, but I surely could. So if I come over to the roles and I scroll down, you can see that I could add some classification variables. I could add interaction effects. I could partition my data. But let's just add in this credit class. I think that's all. Maybe acquisition. No, we'll leave it with credit class. We can always come back. So it immediately updates, runs, and gives me my output. So I have these three graphs on the first screen. This is my fit summary, and then I have my residual plot, and then I have my confusion matrix. I'm going to talk about all of these individually, but let's separate them so they are on their own tabs. I'm going to go to the options on the far right pane, scroll down, and eventually I will get to model display. I'm going to select fit, and then I'm going to select stack. So now I have these tabs at the top that indicate which graph I'm looking at. Again, it's just my preference to close these side panes until I need them. Gives me a little bit more real estate. So we can quickly see total days over plan, days suspended, late payments, all of these are significant, and we are evaluating this at the zero point zero 0.05 level. This is indicated here by this blue bar. I could drag it if I wanted, either way. And you can always undo. So I can undo my last action. That way my bar got back to where I wanted it. And then you can see I have a lot of variables that were not statistically significant at the 0.05 level. And we should have a little scroll bar over here because I had more. There we go. And so I can remove these from the model. I could use variable selection, but let's just talk about what we have right here. So if I go to the top, I have my logistic regression. It's telling me what is my variable, what event are we testing on, and so our one is our customers that we've lost. Here's our KS statistic. It's using the Yalden at a 0.4942. So we'd like to get that up a little bit. The number of used observations, the number of unused observations. Let's talk about that for a minute as well. So one thing that all of our models do in visual statistics is called complete case analysis. And what that means is if there's a missing data item, so if I'm missing a total late payment, but I have data for everything else, if I have a missing value, it will remove the entire observation. So we'll take a look at how we can fix that in some of the options that we're going to take a look at. The other thing that's important to mention is that visual statistics only does binary logistic regression. Okay, so that is a function of the software, and we only have binary logistic regression. So let's then pop over and see if our residuals are telling us anything. I got some noise here, got some outliers over here. You can select them. There we go. Then I could right click and I could do this new filter from selection, include only selection, and write those residuals out so I could look at them. I'm not going to do that. We don't have that much time today. I do want to point out that you have some other choices here. You could use the Pearson, you can use the standardized Pearson as well. You could see a histogram. As far as our assessment plots go, we have the confusion matrix. And then if I right click, you'll see we have the lift, the ROC, and the misclassifications. So it looks like for my ones, I have a fair amount of misclassifications here. So let's see if I can clean this up using some of my options for logistic regression. I'm going to go over and let's look at these options. So our event level 1, yes, maybe we want to turn on informative missingness. And what that will do is it will sub in a substitute value, and by default it will use the mean as the substitute value. So if I am missing, again, say total days over plan, it will substitute the mean total days over plan from all the other observations for the missing observation. I do not have a variable selection method. I could select one. I like fast backward. So you can see our non-statistically significant observations have been removed. Could change my significant level. Really depends on your industry, how big your data is. My link function, I'm going to leave Logit. I'll leave 20 bins, that's fine. My prediction cutoff is at 0.5. We'll have to see if that's good. We could change, our predicted probability to linear predictor. I'm going to leave all that. We could see the variable selection plot. We could add that in. Okay, so I think my Yalden changed just a tiny bit. Let's go and look at some of these other plots. So my variable selection, these are the steps for removing non-statistically significant data items. Again, our residuals, same sort of story. We have a bunch hovering here at 0, which is not a big surprise because this is 0s and 1s, and then a bunch over here at 1s. But we do have these outliers that we might want to investigate. Then we can go to our assessment plots. And I'd like to start with our confusion matrix. So down here in the corner are the ones and the observed ones. So they're predicted and observed. These are my true positives. So this is saying about 30% of my data was a true positive. Remember my churn rate was 12%, and this is based on a 0.5 prediction cutoff. So we're going to have to maybe make some changes here. Here's our true negatives. All right, so let's take a look at. All right, so again, if I hover, this is the same information. I've got that 2,101 true positives, lots of false negatives, and look how good it looks over here. I have very few false negatives for my zeros. Let's take a look at our ROC chart. So this dotted line is where the sum of the sensitivity and specificity are maximized. This is the optimal cutoff point. And look at that, it's a 0.17. The software uses a default of 0.50. So let's go change that. Here's my cutoff, and I'm going to drag this down to a 0.17 and then let it run again. And let's see if this cleaned up my misclassification. So it did. So I have a lot more true positives and less false negatives. But I have more incorrect predictions for my zeros. Let's go back to our fit summary. We do have a lot of other statistics that you could use if you're interested. So you're not limited to that. That's just the default. Not sure that we're getting a lot. We know what is statistically significant. There are a lot of other things that we could do to try to improve this model. We could add in interactions. We could add in splines. Over here in new data is where I would create an interaction effect or a spline effect. But given the time we have, I would like to show one more quick little thing before we wrap up. I want to go ahead and do some by group processing. So if I scroll down, I have this group by option. And when I select that, you see I have cluster ID. So I could select OK. And so these are those clusters that I wrote out previously. And now my fit summary, we're looking at the R square here, and then the effect. And so you can see our estimated income just for group 5 was statistically significant. And so the darker the purple, the higher the significance. These are our groups. Let's get rid of that -1. That's just a byproduct of writing those out. So I'm going to use my filters, and I'm going to select new filter, and I'm going to grab, there we go, cluster ID, and I'm going to remove that. And let's get rid of missings as well, if there are any. So now the logistic regression has been run 4 times, 1 for each cluster. 5 times, sorry, we have 5 clusters. Let's go look at our variable selection. This is now by cluster. It's very messy. So looking at these R squared, nothing is real. I mean, the 0.3 is still not significant. But as far as how the different data items may pertain to each different cluster is very interesting. So we only have these 3 at the bottom that are statistically significant across all. No, we have those 3 and then 2 more. So it looks like we have 5 that are statistically significant, and then this a couple, no, just those that are statistically significant across all of the clusters. A little bit of a tongue twister. Okay, I'm going to go ahead and remove that cluster, and I want to show you one more thing. So as a viewer, you may want to add in some controls, and we saw them over here, but we didn't really use them. So I'm just going to drag the button bar to the top, and then I want to go ahead and assign the region, which I think that we already found doesn't really make a big difference, but I want to show you how to do this, and then I'll set up the actions and I'll select automatic actions. So right now this is for all of my regions. If I'm interested in a specific region, I can select that. I can clear it and it'll go back to all of the regions. And so we see that there is a difference between the regions as far as what data items are significant. Okay, there's a lot more that we could take a look at, but I think our time is up. Again, You go through visual analytics to get to visual statistics. And then within visual statistics, we have lots of models available. We also have visual data mining and machine learning, which is available as well. Thank you for attending my session. As I mentioned, VIA for Learners is free to anyone who has a .edu email address. If you are not part of the academic community, you can try VIA for free for 14 days. Feel free to reach out to me at linda.jordan@sas.com for any follow-up questions. And thanks again.